Hello friends, today we will see the addition of vectors. Suppose a vectors initiate from A and end at B, that is AB vector. Another vector initiate from B and end it with C. Then the displacement of two vectors will be given by AC vector, and that can be represented as vector AB plus vector BC is equals to vector AC. This is known as the triangle law of vector addition. In general, if a one vector is there A bar, another vector is there B bar. So we take a bar as it is vector and we displace the B bar without changing the direction, and we take the terminal point of A bar as initial point of B bar. Then we get the final vector here A, B, C. Then AC will represent A bar plus B bar. So this is known as the triangle law of the vectors. Now, if we take C as the initial point of A bar, AC vector, and A is the terminal point, then AB vector start from A ending with B. BC vector start from B ending with the C, and CA vector start from C ending at the A, and so we can see that we have started from A and end with A, and so total displacement is 0, and so we can write that vector AB plus BC plus CA is equals to 0. Also, if we have vector A bar and here vector B bar, then another vector AC, this is AB and C, and AC will be given by A bar plus B bar. Now suppose we represent the BC's opposite direction with the same magnitude B bar vector, then direction is opposite, so it is minus B bar, then it is BC dash, and AC dash they will represent us A bar minus B bar, will give us difference of two vectors A bar and B bar. Now suppose two vectors are there which represents the adjacent side of parallelogram, vector A bar and vector B bar. Gives us the adjacent side of parallelogram, and we draw like this with two sides. Then here opposite vectors are equal, so this will be B bar and this will be A bar, and then we draw the diagonal. Then by triangle law now, diagonal will represent A bar plus B bar, and so this is known as the parallelogram law of vector addition. So parallelogram law of vector addition is that if A bar and B bar are representing adjoint side of the parallelogram, then A bar plus B bar will represent the diagonal of the parallelogram. Now we will see properties of vector addition. So first property is that vector addition is commutative, like that way we can take. A bar plus B bar equals to B bar plus A bar. So how we can see here? So we take a parallelogram ABCD by the vectors. Four vectors AB, BC, AD and CD are there. So AB vector we have with the A bar magnitude and BC vector we have with the B bar magnitude and AC vector will be given by triangle law, that is A bar plus B bar, and so we can say that vector AC equals to A bar plus B bar. Now we know that the AB magnitude A bar and B bar, so the opposite sides of parallelogram equal and parallel. So BC magnitude is the B bar, so AD magnitude will be also B bar and CD magnitude will be A bar. So for triangle ADC we can write AC equals to B bar plus A bar. So for triangle ABC it will be A bar plus B bar equals to AC and for triangle ADC it will be B bar plus A bar. So both are representing vector AC and so we can say that A bar plus B bar equals to B bar plus A bar. Now we will show that for three vectors A bar, B bar and C bar, the addition of vector is associative, means A bar plus B bar group with add with the C bar is equals to A bar add with the B bar plus C bar. So here we have one vector PQ which represent A bar, another vector QR which represent B bar, then PR will represent us to A bar plus B bar, and so by triangle law we can write A bar plus B bar equals to vector PQ plus QR is equals to PR. Now another vector RS we take with the C bar, then here we get vector PS. So vector PS is equals to PR plus RS, that by triangle law, and so PR will use the A bar plus B bar plus C bar. Now somebody takes that our vector PQ is there with the A bar magnitude, vector QR is there with the B bar magnitude, vector CS there with the C bar magnitude, and somebody takes the QS, then by triangle law QS vector will be B bar plus C bar, so we can write B bar plus C bar equals to QR plus RS, which will give us QS vector, and here by in triangle PQS we can give us PS equals to PQ plus QS, then it will be A bar plus B bar plus C bar. So if we take triangle PQR and then triangle PRS, then we are getting A bar plus B bar plus C bar, but final vector we are getting PS. And same way if we take PQR and QRS, then also we are getting final vector PS, and so we can say that vector addition is commutative. Now A bar is any vector we add with the zero vector, means null vector, then it will give us A bar, and so zero vector is known as additive identity for vectors